Okay, so daily transaction in the sense, for example, if you are going to the banks, so the banks, in the banks there is a lot of customers are there. So you and me are also the customer of some one of the bank, and we are made a lot of transactions by withdrawing, by depositing some amounts into the bank in our accounts. So those transactions captured by using a system, right? So whatever the transactions happen, those are stored in our database. Okay, so if you want to design this OLTP system database, so OLTP database, so definitely we required one modeling, right? So how you are going to design this database for OLTP system? So the kind of modeling we are using is ER modeling. What is ER? Entity relational modeling. Okay, what do you mean by entity? So entity is nothing but a one table here. For example, product is one entity, category is another entity, subcategory is another entity, and customer table is an entity, and location is one entity. Okay, so these are different kind of entities in our OLTP system. Okay, right. See here, in OLTP system, the modeling we are using is entity relation modeling. Entity is nothing but a tables. So in between the tables we are going to make relationships. What kind of relationships we are making? So primary key and foreign key relationships. In the OLTP system, the relationships we are calling is primary key and foreign key relationships. So here if you observe in this OLTP system, we have two entities. The definition of entity is, it's a real-time object. Product is a real-time object. Customer is a real-time object. So in this product table, the product ID is the primary key column. So we know what is a primary key column. It is not allowing any duplicate values and no null values. So in the product table there are two products are there, 1, 2 Santur Nirma soaps. And in the customer table, this is CID, customer ID 1, 2, 3. There are 3 customers we have. This is another entity. In CID, this is the primary key column. So total we have 2 entities: product entity, customer entity. Okay, and you can maintain lot of entities based on your business and your project. Location entity, store entity. These are the different kind of entities. So in OLTP system, these entities we are calling master tables. This product table, customer table, and location table. Some of the examples master tables are product table, customer, location, store, date. Okay, all these these are master tables. So what about this table? If you observe here, this is the transactional table. In this table, every transaction is tracked. For example, this particular product ID. What is this one? One is nothing but Santur. CID means customer ID RAM. Purchasing 4, quantity and the amount is 200. How can you say that this product ID is 1 is equal to this one and CID 1 equal to this one? Because we are going to make a primary key foreign key relationships with this transaction table and master tables. So this product ID is the foreign key column of the primary key column product ID. It is referring the primary key column of the product table. And this CID is the customer table. This foreign key column is referring the primary key column of the customer table. Okay, so and this is the quantity and these are the measure values and this is the amount. So whenever you want to see the information like what is the product, who is the customer, what is the quantity and what is the amount, if you want to see, so it just make a relationship with these IDs, select star from this transaction table, inner join with product table on which column? Product ID column equal to product ID column and customer ID column equal to customer ID column. So you can get the customer information, product information for this corresponding record. So in the OLTP system we have master tables and transaction tables. The transaction tables are this kind of measure values, transaction tables, sales. One example is sales table. Okay, so this is the OLTP system. In our OLTP system, the tables are very normalized tables, small tables. Why we are making these are very small tables is most of the time in the OLTP system we are inserting the data and we are updating the data. So for insertion and updations, the table should be in normalized format. Then the system will be in more accuracy. The insert operations, update operations will do very fastly. If your tables are having a lot of number of columns and denormalized formats, then it is difficult to update inserts. Okay, because we are not doing more select statements on this OLTP system, because there is a lot of customers are working and accessing this OLTP system. For example, if you are seeing the banks, so the banking system, there is a lot of employees are working on this database. So again you are going to do this analysis on this particular OLTP system by selecting the data for SSRS reporting. Definitely the system will hang out. The performance is very dull. So that's why we are using this OLTP system only capturing the information like insertion, updations only. Got it? So you are capturing a lot of information in OLTP system, whatever that is the SQL server or Oracle or whatever. Based on your information, whatever the information you have stored, by using this information, what I am going to do here, we want to implement a business intelligence. Okay, so if you want to implement this business intelligence, you have to apply some analysis on the data. You have to apply some analysis on the data. On which data? So this is not a formatted data in OLTP system. Whatever the data you have, this is not a formatted data. So for that, what I am going to do here, we are going to load this data. We are going to ETL this data from OLTP system to another system. That is, we are calling the data warehousing or OLAP system. Data warehouse or OLAP system. OLAP. What do you mean by data warehousing? A data warehouse have a lot of historical information. Daily in the non-business hours timing, we are loading the data from source to your OLTP system to this data warehousing database. This data we are loading based on your business requirements. So if you want to design this data warehousing or a OLAP system, what kind of modeling we are using? What kind of modeling we are using? That is dimensional modeling. In OLTP system we are using entity relation. And what kind of relationships we have? Primary key and foreign key. But in data warehousing or OLAP systems, so the modeling we are using, we are calling that is dimensional modeling. So in OLTP system, these kind of tables, product table, customer table, store, location, all these kind of tables we are calling master tables. Right? But in this dimension modeling, we are calling these tables are dimension tables. We are calling these are dimension tables. Dim product, dim customer, dim location, dim store, dim date. These are the sum of dimension tables. And what about these tables we are calling? What is a dimension table? So dimension tables having these kind of descriptive textual information. Product table, it has a product information. What are the products you have in your store, and what are the stores you have in your city, and what are the locations your stores are existing, in which locations your stores are existing, and what are the customers you have, the customer information you can keep. For example, in these dimension tables, whenever you are coming to your data warehousing, in your OLTP system, the customer information we are maintaining in two tables. Why we are keeping this information in two tables? One is this customer and another one is customer detailed information. Customer detailed information means, so what is his address, what is his mobile number, and what is his zip code, pin code, and what is the marital status. All this kind of unnecessary information we are storing in another table. for normalization purpose. Normalization means making small tables and reducing the redundancy. Redundancy is nothing but duplication of the data. So try to make any table uniqueness. So whatever the information we are using rare case, that information we are tracking and storing in a different table. Okay, so this is the customer table and customer detail table. The same table, if you are coming to this data warehousing, same table if you are coming to the data warehousing, so we are combining this customer table and customer detail table. All information we are keeping in a single table only, because in the data warehousing mostly we are maintaining a denormalized tables. Okay, right. If you observe one thing here, these are all the dimension tables: dim product, dim customer. These two are some examples. So how these tables are changing the key values and what are the columns existing whenever we are comparing with OLTP system. This product ID is the primary key column in OLTP system. So this primary key column is coming into your data warehousing dimension modeling. So this will referring this column. So this column we are calling here is business key column. Business key column. Because if you observe in our loading in incremental loading, slowly changing dimension, we are comparing this primary key column of your source system OLTP system to your data warehousing dimension table, product table with the product ID. Both are same. So before we are going to load the data, we will compare this product ID with this product ID, this product ID with this product. Whether this particular product ID is already existing in your system or not. If it is already existing, that means this is the old product. So you have to update the record. Or if you have this product ID is not existing, this is a new product ID, then that is you have to insert as a new record. So you are comparing on this product ID column. What about this P key? This is a kind of sequence number. Automatically it will generate this number 1, 2, 3, 4, 5 like this. Sequence number. This column we are calling a surrogate key. This column we are calling surrogate key. Surrogate key means it will generate the sequence number. Whenever you are inserting a new row, it will give a new number, sequence number. Why we are maintaining this surrogate key column? This will identify each row uniquely. Okay, this will identify each row uniquely. In this customer table also CKE, C key, P key, and this CID is nothing but the primary key column of the customer table. We are comparing with this CID. And if you are coming to this fact table, whatever the transaction table you have in your OLTP system, that here we are calling it a fact tables. Okay, fact tables. Here it is fact sales. So inside this fact table, what kind of values we are storing is measure values. Measure values means whatever the value you can measure, you can sum up, you can add the value, you can group the value. Those are calling measure values like amounts, quantities. What is this quantity? What is the amount? But without this particular product and a particular customer, this order, this quantity and amount is a meaningless. What do you mean by 4? What do you mean by 200? Yes, whenever you are joining this table with the dimension tables based on the P key, C key. If you observe one thing here, this P key column and C key column both having these two are surrogate key columns. These are behaving like a primary key column, but in dimension modeling there is no concept of primary key column. We are calling those are surrogate key columns. This is also surrogate key columns. So these surrogate key columns, whatever the surrogate key columns existing for each dimension, those all are existing in your fact table. Those all are existing in your fact table. See, this P key column E is a foreign key column, is referring the surrogate key column of the dimension table, and this C key column is referring the customer table, dim customer table surrogate key column. So whenever you want to see the data, you can join this fact table with the dim product and dim customer. Right? Dim product and dim customer, you can join with this table and you can find out the information. Understood? Right. So the dimension modeling we are using here. Inside the dimension modeling, there are two kind of schema designings. Those two are star schema and snowflake schema. What do you mean by a star schema? Star schema is nothing but you have this fact table. So inside this fact table you have quantity, you have quantity and amount. And whatever the relationships you have with the, for example, primary key columns. See, this is a product key column. You have a relationship with the product table. And the customer key. So this is customer table. And this customer table having surrogate key C key. Right, and one more having store table and store key, and one more having location key, having location table L key. So whatever the surrogate, each dimension table having a surrogate key column. So those surrogate key columns all are existing in your fact table. This is the fact table. and all are the dimension tables. If you observe, all the dimension tables having a direct relationship with the fact table. So this we are calling star schema. Whenever we are creating a data warehousing database, so if you want to create your data warehouse database by using a star schema, so you have to maintain like this way. Each dimension table, whatever the dimension tables you have, should be direct relationship with your fact table. Should be direct relationship with your fact table. This customer table, for example, dim customer having relationship with the fact table based on the customer key column. Product table, dim product table having direct relationship with the product key column in the fact table. The same way, location, store, date, dimension. This is the star schema. Star schema means all the dimension tables should have a direct relationship with the fact table. Kind of a surrogate key, foreign key relationship. Right? So in this star schema, the tables are in a denormalized format. The tables are in denormalized formats. So whenever you are, see here in the, for example, in customer table, all the customer information we are maintaining in one table, and we are making direct relationship with the fact tables. So in these kind of scenarios, you can make less number of joins whenever you are going to fetch the data, because all the tables have a direct relationship and those tables are denormalized tables. There is no child tables for this dimension table. For example, product table. So this product table having one more child dimension table, that is product subcategory. Subcategory table, dimension subcategory. And this subcategory table having relationship category table. For example, if you want to see the information a particular product, this product belongs to which category and which subcategory, and what is the order and what is the amount. So you have to join with this fact table based on the product key and the product table product key. And then again, if you want to take the subcategory, you have to join this product table. Inside this product table, we are maintaining the subcategory key column. This subcategory key column with the subcategory table key column. And this subcategory table, if you want to join with the category table, so this category key with the category key column of the category table. So you have to make this many number of joins. So this kind of schema we are calling a snowflake schema. In snowflake schema, some of the dimension tables don't have a direct relationship with the fact table. Here the subcategory column and category column don't have a direct relationship with the fact table. Why we are not maintaining the direct relationship? Here if you observe, this fact table having relationship with the product table. So the product table having relationship with subcategory table, and subcategory table having relationship with category table. Right? So yes, if you want to maintain, you can directly maintain the subcategory relationship with the directly with fact table, and category table with the direct fact table relationship. Why we are not keeping the relationship? The reason is to reduce the redundancy, duplication. What exactly the duplication? For example, this is a product table, dim product. and this is a subcategory table. And this is category table. This product table having product ID, product name Santur, Nirma, okay. Name 1, 2, 3, dough, and the next are sofa, dining table, right. So these three are related to a kind of what kind of category these are? Washing. So the subcategory type is washing, and these two are home kitchen appliance. And what is the category? This is the subcategory. Categories, and these all are belongs to all are related to home only. So if you want to maintain all information in one table, yes, you can do like this way. In product table only. What is the product name? What is the subcategory? What is the category? So if you observe here, it is repeating this many number of times. Washing, washing, washing. Home appliance, home appliance. All these are coming under category home. So instead of keeping these many duplication of the data, what I am going to do here, subcategory ID, and what are the subcategories we have? Washing is one, and home appliance is 1, 1, 2. And what about this category? Category ID, C name 1, home. Right? So instead of maintaining this all this information here, so the IDs you can maintain here. 1, 1, 1, 2, 2, and there is no category. This is yes ID. And here we are maintaining CID 1, 1. See, if you want to make a relationship, the product table SID with this SID, and this subcategory table CID with this CID, you can make the relationship and you can get the information. So we are reducing a lot of information by using this key columns. You don't need to maintain washing, washing, washing again. Home appliance, home appliance. It's a kind of reducing the duplication of the data, and you can reduce the, you can save the memory also. Understood? So this way you can maintain three tables, child tables with the product table relationship with category, subcategory with the category table. So in these kind of scenarios we are using snowflake schema. Right? So these are the two dimensions we have. What is a dimension table? What is a fact table? fact table having a key values and measure values. What is a dimension table? And what is the role playing dimension? What is the conformed dimension? Conformed dimension means, so before that, what is a data mart? Data mart is the one business area, one unit of work in your entire organization. So you have a lot of business. Inside the business, marketing department is one business area, and sales department is one business area. One data mart we are going to create for this one means, so all the sales for example, this is marketing. All the marketing information and transactions are coming into store into this marketing fact table. What are the dimension tables we have, and we are making the relationship with the marketing fact table. So this is one data mart. The same way, this is sales. Whatever the sales information is coming and stored into the sales fact table, and this is having some relationships. Okay, and so this is one data mart. So in this way, for example, your employee HR information. So in the HR table, we are going to maintain all the salaries and transactions, everything. So that is one data mart. So if you are combining all these data marts, that is a data warehousing. In there are two ways we can design this data warehousing. First, bottom to top approach. First, you can design the data marts first, and you can combine this data marts, is called data warehousing. And sometimes first we are designing this data warehousings, and after we are creating the data marts. Whatever the data marts we are requiring, we can separate and we can create the data marts. Okay, so in these data marts, some of the dimension tables are shareable. For example, a dim customer. So for that dim customer are marketing. So whatever the peoples are doing marketing, those peoples are the employees. So in HR data mart and this marketing data mart, both this employee table should be shareable. So that table, that dimension table we are using in another data mart and this data mart. So that kind of data marts we are calling conformed dimension. And sometimes the dim dimension table, dim date dimension. So that date dimension table, the same table is referring more than 2 times. For example, inserted date, okay, and the same way whenever the transaction date. These two key columns are referring the both date dimension table. A fact table having more than one time the relationship with the single table, that is called the role-playing dimension. Role-playing dimension table. So, and we have one more dimension table, that is junk dimension. What exactly a junk dimension? Junk dimension table means sometimes in data warehousing we are maintaining some flags and unnecessary repeatedly data like yes or no, some boolean values like true, false. So these kind of information we are keeping in one dimension table and with the one key values. So instead of maintaining these values in your fact table, so you can keep 1, 2, 3, 4 values. Because yes or no, these are repetitive values. Instead of repeating these strings, you can keep in one table and you can maintain in that fact table 1 to the key values. So this kind of information we are calling junk dimension. Role-playing dimension, conformed dimension, junk dimension. Okay, these are the dimension types. And we have measures, additive measure measure types. These are semi-additive and non-additive. So these is additive, semi-additive, non-additive means a measure value. Here if you see this quantity, yes, you can combine and you can calculate this quantity and amount these two measures with any dimension. So product wise what is the quantity and customer wise what is the quantity. So you can use this quantity value with any kind of dimension, right? So these kind of measures we are calling additive measures, fully additive measures. And semi-additive means, so some of the measure values we are calculating with the corresponding with the sum of the dimension tables only. Those are semi-additive. So some of the dimensions, some of the measure values we are not calculating with the corresponding with any of the dimension table. Those are non-additive dimensions. Okay, right. So there is one table is a factless fact table. What exactly a factless fact table? Factless means this is a fact table but there is no measure values, this kind of quantity amounts. That fact table having only key values. It is behaving like a kind of a bridge table between one fact table and another fact table. We are keeping some key values inside the table, and whenever you want to join these two fact tables, you can make that joins based on this key columns. That is a factless fact table. There is no measure values inside a fact table. So that is called the factless fact table. Okay. So whenever these people are designing this modeling, so they will create one bus matrix modeling. Bus matrix modeling means what are the fact tables you have. For example, sales fact table, marketing. There is a one more fact table. So these fact tables, and what are the dimension tables? Customer, product, store, location, all these things. And these people will maintain what is the, and which this customer table having a relationship with in which is involved in which data mart. This sales fact table, yes. Marketing table, yes. So this product table having also a relationship. Store don't have only marketing, and what are the relationship? These are all dimension tables, and these dimension tables having relationship with which fact table. So that kind of information you can maintain in a bus matrix. So you can easily observe, okay, this fact table having relationship with these dimension tables. So the data modeling, whoever doing, they will create this data bus matrix modeling. Okay. So by seeing this, by looking on this bus matrix, you can easily identify that. Right. So this is the data warehousing concept, and this why we are using this OLTP system. In SSAS we are going to create this schema. We have to design this schema. In OLAP systems, this star schema or snowflake schema, whatever the schema you are expecting, that schema you have to design in before you are going to create your cube database.